This is problem solving and programming techniques. We are moving into chapter 3, where we'll be talking about functions. First, we'll define what a function is. We've already seen them. We'll talk about what custom functions are, how to define a function, how to call those functions. We'll talk about parameters and arguments, returning functions versus void functions, the concept of none, scope, and then we'll touch on error handling. As this slide asks, we have to figure out what is a function. And the easiest way to think about it is a function is a piece of code that I want to be able to use multiple times. So the easiest way for me to reuse it is to give it a name. And we've already played with some functions. You can see we have the built-in functions listed at the bottom. We've used print to print stuff to the console. We've used input to ask a question and get information back from the user. And we've used int to convert a number into an integer. So each one of these is a function. And we can tell that because we see the parentheses on the back end. To write our own functions, we're going to use the keyword def, which stands for define, and then we will give our function a name, and we'll have parentheses, and then we'll have a block of code that does what we want it to do. And then on the bottom line, you can see we're calling our function greet. As you can see, I've copied our sample code into Visual Studio Code so that we can see what it does. I've defined a function named greet with the keyword def, and then the name greet, and I have empty parentheses here and a colon, just like I would for a loop or an if, LFL. It all ends with the colon, and then I have a block of code. So this block of code is controlled by my function. And then we can go down here, and I call my function just like I would call print or int or any other function that I have. And you see when I hover over it, Visual Studio Code will show me that I'm calling a function, and it will have the definition and the name, and you can see it says none here. That's something that we're going to talk about in a few minutes, but this is the information I need to know in order to call my function. So when Python comes into my code, it's going to start on line 1, and it's going to define my function in line 2, but it doesn't actually do anything with that function. It holds on to that information so that whenever I want to call the function, it knows what to do. So when I get down here, line 4, or now 5, this is the entry point for my code. This is going to be the first thing that actually gets executed. So when I run it, you will see it does print, hello, welcome to Python. As you can see, we have an example of the syntax down here. We just saw it in our coding video as well. Function names, they have to follow Python naming conventions. I can't rename if. If is a keyword. I can't redefine the define keyword. So I have to leave those keywords alone because they have special meanings. As we discussed in the coding example, defining the function does not actually run it. It's just being saved in Python so that it's available to call later. So if we want to execute it, we have to call that function by name. We have to have the parentheses on the back end. Many times when we write functions, we have to pass information into them that they need to perform whatever task we're asking those functions to do. If I were to ask my son to go mow the yard, I'm going to let him use a lawnmower that I provide. I'm not going to expect him to go pick one up somewhere or go find one. I'm going to provide that for him because he needs it to complete the task that I've asked him to do. So we have parameters that we define when we create our function. that allow us to pass information into our function for it to use whenever it's running our code block. When we call our function, we pass in arguments, and those arguments are going to be mapped to the parameters whenever it actually executes the function. There is a difference between parameters and arguments, but in the real world, if you get into programming whenever you leave school, people are going to use these terms interchangeably. They'll say, you missed your parameter here, you missed your argument. Basically, you forgot to put something in when you were calling your function. Technically, it's not correct, but we know what somebody's talking about whenever they say parameters or arguments. We're talking about passing information from a function call into the function so that it can be used in the code execution. Once again, I've copied our sample code into Visual Studio Code so that we can see what happens when we run this. So I have my definition of the function greet. I'm passing in the parameter name, and then it's going to print. Notice I have the F in front of my quotation mark. This is printf, so we're going to format this. It lets me put my variable inside of my string using the curly braces. Then I'm going to call greet, which is my function. Once again, this is the entry point. This is the first thing that's actually going to be executed. And I'm going to pass in the string Alice. So let's go ahead and run that. And you can see it says hello Alice. I could come in here and change Alice to Bob. Now save, hit the up key, and now it says hello Bob. I can put anything in here that I want and it would still work. In fact, I think, yes, this says any for the data type. So I could actually come in here and put 3.14. And then Control S to save here. Clear that out. And you can see it actually takes the float that I typed in there and it will print that out. So I can pass anything through right now and it will print it. Remember, this is my parameter because this is at the definition. This is my argument that I'm passing to my function. Just like we use parameters and arguments to pass data into a function, sometimes I want to get things out of my function. So in this example, we have defined a function named add, and we're passing in two parameters this time, A and B. And then we're going to return A plus B. Once again, I've copied our sample code into Visual Studio Code so that we can see what it does. We've defined our function add. It accepts A and B, and then it's going to return A plus B. So I'm calling it here with the function add, and I'm passing in the arguments 3 and 5. And I know that this is going to return any, so actually I can pass a float or an integer into this. In fact, I can pass a string into this. So it's going to return some value. So I'm going to store that into result, and then I will print out result. So let's go ahead and run that. And you can see it gives me 8. If I were to come in here and change these to floats, so 3.2 and 5.5, and then save it, rerun it, now I get 8.7. If I were to come in and turn this into string by putting quotes around each one of these parameters, and then save it, you can see it concatenated or added the two strings together. So it gets treated like this as letters: 3, a period, a 2, a 5, and we're talking just characters. So it puts them all together. So I have 3.2, 5.5, no spaces in between them. But each time it's returning this value and it gets stored in results. Sometimes I don't need my function to give me anything whenever it's done. So I would use a void function. In business, there are two main forms of business. One business sells you a product, the other one performs a service. So we do functions the same way. Some functions give us a product back or they return something to us. Other functions, they just perform a service, and whenever they're done performing the service, then we are done with that function. So this is a void function, and the service that it provides is it prints this is a void function. I've copied this sample code over as well so that we can look at it. And as we discussed earlier, if I run this code, it prints this is a void function. And it does not return anything, but this just does a service. I could still pass parameters into this. So I could say, I have a variable named jump. And I can come in and change this, put curly braces here, and put my variable. And then I'll save that. Now, in this case, I did not pass anything in. So when I run this, it's going to throw an error message. So if I have a parameter, I have to pass an argument. Let me save that. So this is still a void function, and it's taking a parameter now. Technically, all functions in Python return something, but void functions return the keyword none. And none is a word in Python that means there's nothing here. In other programming languages and throughout computing, you'll often hear the word null. None is Python's version of null. Once again, here's our sample code. We have a definition for display message. As you can see, display message prints this is a void function, and then we call display message and we store what's returned into myvar, and then we print myvar. Now, if we hover over display message, we see it's a function and it returns none. So when I run this, let's see what happens. You can see it says this is a void function, and then it prints none. Now that we can work with functions, we have to talk about something called scope. Now, scope is a huge subject that could be its own slideshow. We're just going to talk about it real quick. If you go further in software development, you're going to learn a lot about scope and how it's different in different programming languages, and scope can be a huge aggravation whenever you start writing software. But the basic idea is we have local variables and global variables. Local variables, they just live in particular areas for a small amount of time. Global variables, they can be accessed throughout your program, so they're globally available. Here's our sample code. We can see that x equals 10, so we're putting 10 inside the variable named x. Then we define a function named func, and inside of func, we put 5 in a variable named y, and then the function prints y, and that's it for the function. So this is a void function that performs the service. And then on line 7, we run our function, and then we print x. Remember, x is global. It lives outside of our function. Y is a local variable that lives inside of our function. Think of scope. It means, where does my variable live? So let's go and run this code. And you can see it prints 5 from inside my function whenever I hit line 7, and then it prints 10. So you can see here we have print y is commented out. You're going to save that, and you can see there's a little squiggle down here, and it says y is not defined. Now, y is defined up here, but that's local, so it doesn't exist in the global scope for the rest of my program. So if I run this, I get an error message. So let's go and comment this back out, and we're going to see something interesting. If I come in here and I say x equals 3, and then I print x, save it, and I'm going to clear this. You can see inside of my function, x is 3, and I print x, and it prints 3. Y is 5, I print y, and it prints 5. And then I come down here, this x is 10, so when it gets printed out, the global x, it prints 10. So here I have 2 different variables named x. The global variable x is 10, and then the local variable x is 3. This is where things get interesting when you start writing software and you're using the same variable name, because it could be in 2 different scopes in different parts of your program, like this x is. So it has 2 different values. And this is also when we want to make sure that we have good names for our variables, because if it was inside this function, maybe it serves a different purpose. I could use a variable name other than x. In fact, since I already have an x, it might be a good idea to just change this to z. So now there's no confusion. We know that that is a different variable. Now that we've tackled scope in one slide, we're going to move it into error handling, which is another one of those things that it could be its own slideshow, but we're just going to get a quick overview. So in Python, we get the keyword try and accept, and we use these keywords along with blocks, like we can see in our sample code, to handle error messages that may come up and stop our program from working. And when we're talking about try and accept, I want you to kind of use the phrases that we have listed here. You know, my code works great, except when people try to divide by 0. We'll try to divide what our users are giving us, and we'll see what happens. So try is, we're going to try to run this code. Accept is the keyword that says, oh, well, that broke. It's because, you know, they did this, so it worked great, except when they divided by 0. Now we'll look at our sample code. You can see that we have our try block, and inside of our try block, we have a variable named num, and we are taking an input and turning it into an integer, and then we're dividing 10 by that integer and printing out the result. So any error messages that get thrown in these two lines of code are going to get handled by either this zero division error, which says I can't divide by 0, or this value error. Now, if these errors are thrown, then I can handle them. If this throws an error that is not in this list, it will still break the program. But let's go ahead and run this, and we'll see how this works. So it says enter a number. So first thing I'm going to do, put in 0. And we can see that it says I can't divide by 0. So that works the way that I want it to work. Now, let's see what happens when I put 2 in there. So this should work fine. I should not have any error messages that get handled. And you can see it gives me 5.0. So now it says enter a number. I know that whenever I input certain types of numbers in as a string, the int can't handle it. So I'm going to enter 3.14. This is technically a number, but it's a float. But if it were converted to a float and then converted to an int, it would work. But I know that this is just an issue in the int function. But you'll see it does not recognize 3.14 in string format as a number. So let's say I had other errors I was concerned about. There is a way to handle that. I can catch everything. I want to put a single, or I want to use the apostrophe, so I'm going to put double quotes. So now, some people talk about Pokemon error handling. Well, this is what they're talking about. So I don't care what gets thrown. I'm going to catch everything. I'm going to catch them all. So let's save it. Run my command. And I put 4. Okay, that worked. I run it and I put 0. But now it just says that didn't work. I put my 3.14 again. That didn't work. So at this point, this code cannot break because I'm catching everything. But now my code isn't telling me what the problem is. So my user isn't getting hints on how to make the code work. So I'm going to put this back. So now I have good error messages for dividing by 0. I have good error messages for that's not a number that I can support. But if there's something in here that I don't know to look for, it's still not going to break my code and throw an error message. So that wraps up chapter 3. We defined what a function was. We talked about how to build our custom functions using the keyword define and how to call our function. We talked about parameters and arguments. Parameters are the variables as we're creating our function. Arguments are what we pass into our function. We talked about return functions versus void functions, how return functions give us something back and void functions just perform a service. We talked about none and how none means there's nothing here, and void functions actually return none. And then we talked about scope, which is where variables live, and how we can have global scope, which is a variable that can be accessed throughout the program. And then we have local scope, which is variables that are only inside of our function. And then we talked a little bit about error handling, how we can try to run some code And if it breaks, then we can use that keyword to handle the error messages that are coming in and communicate to the user what the problem was, and maybe give them a hint on how to get the code to function the way that they expect it to work.